to the video solution guide to practice test 4. In the first question, we're going to solve each equation, and we're going to write the equation in whatever box corresponds to the correct solution. So, getting at it, 8x equals 56. That's 8 times x. If I undo multiply, the inverse of multiply is divide. I can do that if I do it to both sides. I get x equals 7. Moving on, I have x plus 5 3/4 equals 8 3/4. I can undo addition with subtraction. I'm going to subtract 5 3/4 from both sides to keep it balanced. And I get x equals 3. Next one, I have x divided by 2 equals 3 5/10. The inverse of division is multiply, so I can multiply both sides by 2. And I get x equals 7. I have 2 1/4 plus x equals 9 1/8. I undo addition with subtraction, so I can subtract 2 1/4 from both sides. I have x equals, and now I have a different denominator, so I need a common denominator before I can solve this. So I'm going to go to eighths, so I get 9 1/8. Take away 2 2/8, multiply top and bottom times 2. And now I can't take 2/8 from 1/8, so I'm going to borrow from the 9. That's 8 8/8. So 8 8/8 plus 1/8 is 8 9/8. Take away 2 2/8. If I subtract, I get 7/8, and 8 minus 2 is 6. The last question, I subtracted 2 56/100 from x. The inverse of subtract is add. So I'm going to do that to both sides. And I get x equals 3. Now I need to write the equations in the appropriate box. So for a solution of 3, we had x minus 2 56/100 equals 44/100. For neither, we have this 2 1/4 plus x equals 9 1/8. For 7, we have a 8x equals 56. And then the last two I put in their appropriate boxes. So that's just finishing it up. Next question. Ed's birthday is less than 16 days away. So his birthday is less than 16. So if I had 16 on a number line, it doesn't include 16. It's less than that, but it's everything to the left of it. It could be 1, it could be 2, it could be 15, it could be lots of things. And she writes the inequality, d is less than 15. Well, that wouldn't include 15, and it would be everything to the left of it. And if I'm wondering if she's correct, she's not, because she didn't include 15 as a possible answer. Ed could be 15 days away. That's less than 16. But Anne said it had to be less than 15. So the answer is no. The reason would be Ed could be 15, and Anne's inequality didn't include 15 as one of its possible solutions. All right, here we go. We want to know which graph is p is less than 10. If you get confused by the symbols, then just pick a value, something to the left. So say 6. Is 6 less than 10? The alligator's eating 10. That looks pretty good. So I should have something over on this side colored in. Pick something on the other side. 12 is less than 10. Well, that's not true. The alligator's not eating the bigger number. So I shouldn't have anything over here. So knowing that, oh, and by the way, it's not equal to 10. I don't have an equal down here. So it should be an open circle because it's not including the value 10. Well, as I go down, this is no good. This one looks pretty good here. This one's no good because it has these values bigger. This one has the right side shaded, but look where they started it. They started it at 9 instead of 10. So B is going to be your solution. All right, for this next one, we're going to choose all the equations that are true if x equals 9. Couple ways you could do this. You could solve each equation like we did in the first question. Or you could substitute in the value 9 and see if it's true. So let's see, this first one we have 32 and 54 hundredths. And I'm going to subtract. Decimal comes straight down. I get a 9. That is 9. I'm going to check it off. And this one I have 9. I'll just substitute that in. Well, 9, be careful. That's 9 divided by 27. And you're going to get something less than 1. So that is not a solution. The next one we have 3/8 times 9 over 1 equals 3 and 3/8. Can't cross reduce, so I get 27/8, which is 27/8 is 3. That's 24 and 3/8. Look at that. It worked when I used 9. Next one, I could put in the 9 here, and I could already see if I add something that's a whole number to something with a decimal part, it's not going to be a whole number answer, but that's the way we would set it up. And we get 7, and we get 17, so it's not a solution. And 5 times 9 equals 45. That's true. So it's a solution to that one. Okay, for this next one, Noah wrote 6 plus 6 is 12. And then he wrote another equation, 6 plus 6 minus n equals 12 minus n. I highlighted the part that was different there. And it looks like we subtracted the same from both sides. And we know that if we do the same thing to both sides of an equation, it stays balanced. It stays equal. So are they balanced? Yep. And the reason is Noah subtracted the same thing from both sides. And when you do this, the equation stays balanced. And that's the same as if you add the same to both sides, multiply both sides by the same amount, or divide both sides by the same amount. All right, Mr. Daniels is organizing a class trip and he wants to spend less than $900. So he buys tickets that are $9.50 a student. And I want an inequality that shows this situation. So I'm going to draw a bar model first. And I want the whole thing to be less than 900. I know that one ticket is $9.50. There's one ticket. 2 tickets. And we have Y tickets. Why is it Y? Because they said it was. All right. Now, if I were to write an equation for this, I know that 9 and 50 hundredths Y, 9, so I have Y groups of 9 and 50 hundredths, is being compared to 900. Now, before I'd write an equation, it's equal to it. But I don't want it to be equal to it. I want it to be less than it. So there you go. There's your equation. Whatever the Y groups of $9.50 is, it needs to be less than 900. And this is your solution. For the next question, we have a manager of a water park keeping track of the amount of money he collects and the number of tickets he sells, or she. And we want to know which is the best description. So as I look at this, I have my money that I earn and the tickets that I sold. I need to sell my tickets before I make my money. So the tickets, that's going to be independent. And the money I make is going to be dependent. Well, this first one's wrong because it says the variable m is independent. The second one's wrong because it says the variable t is dependent. The third one is plausible. It says the variable t is independent. Well, that's good. And it says it doesn't depend on the amount of money collected. That's true. So I think this is looking pretty good. Let's look at the last one. The variable m is independent. Nope, that's wrong. Here's your answer. And just remember, the independent variable is the thing that generally happens ahead of time or is set up ahead of time. Time of day versus temperature. You know the times of the day, even into the future, but you need that before you can measure your temperature. So there you go. Okay, April is paying a dog walking service $30 a week to walk her dog. And we want to complete this table to find out how many dollars she makes walking the dog. So the dollars she makes is going to be $30 for every week, right? So 1 week is $30, 2 weeks is 60. To get to 90, I need 3 weeks. To get to 120, I need 4 weeks. And 5 weeks is going to be 150. And it's as easy as that. Okay, we want to write an equation to show the pattern on the table. To get from A to B, it looks like I'm subtracting 5. Works there. 7 minus 2 is 5. 8 minus 3 is 5. So I'm going to take A, I'm going to subtract 5, and that gives me B. And as I look at my solutions, let's see, B equals A minus 5. That looks like it. So we have a graph of Rudra's walk, and we measured how far she went per second. And so as we look at this, we're looking for the independent and dependent variables. And on a graph, the x-axis should always be your independent variable. And in this case, it is. We knew seconds before we knew how far she would go during those seconds. So the dependent variable is distance. Now the next part is writing an equation. So when x, or the time, is 0, I can see that we've not gone any distance. That makes sense. When the distance is 1, it looks like we have gone 6 feet. Okay? And it's a straight line. If I went half looks like it's about 3 feet, although it's kind of hard to see there. But anyway, if you get the idea here, it looks like to get from 1 to 6, that's times 6, and it's going to be the same for all of them. 0 times 0, 0 times 6, I mean, is also 0. So it looks like I'm taking my time and I'm multiplying it by 6 to get the distance. So that's what we have down here. So to solve this problem, what I would do is I would make a table, look for the pattern, and then write your equation from there. Last question, pretty straightforward. Find t. So I'm going to subtract. I have a t plus 1/4, so I'm going to subtract 1/4 from both sides. And I get t equals, I need a common denominator before I can check. It's going to be 12. And 1/4, I'm going to multiply by 3 here. And I get 3 twelfths. And if I subtract, I get 4 twelfths and 2. And of course, that needs to be simplified. I can divide top and bottom by 4. And I get 2 1/3 as my final reduced answer. And that's it. That's the whole test. Let me know if you have any questions, and good luck to you all.